In this section, we're going to be looking at how to find the steepness of a line, or also called the slope of a line. So to find the slope, we use any 2 points on the line, like here to here, and we find the distance between the y-coordinates, so from here to here. So if we compute that, that distance is going to be, let's see, if we count 1, 2, 3, 1, 2, 3, 4, 5. So it's 5 units away. And we also look at the distance between the x's. So from -3 to -1, that's 1, 2, 2 units. And so this ratio, that represents the distance between this y to this x, so that's my 5, and this distance from here to here, from this x to this x of this point, that is 2 units. This ratio here represents the steepness of my line. So the slope of this line would be 5/2. So again, the way we found the 5, that is the distance between my two y-coordinates, and the denominator is the distance between the x-coordinates. Now, if you do it with the ordered pairs, so if you look at this point, the ordered pair for that is -1, 3, and then this ordered pair has -3, -2 as its coordinates. So the way we found the 5 would be to go 3 minus -2 to find the distance between here and here. And to find the distance between here and here, we would take -1 minus -3. And that's how we would get this slope 5/2. So to find the slope, if you have the graph, you can always do what we did here first and count the units from one y-coordinate to the other y-coordinate, and then count the units between the two x-coordinates, and that's one way to find the slope. But if we wanted to find the slope using the ordered pairs, then the formula would be the difference between the y-coordinates, so y2 minus y1, and x2 minus x1. Now, sometimes we refer to the slope also as rise over run, because rise, that's, in a sense, if you're looking from this point to this point, it's how much you have to rise to get from this point to this point, from that point to that point, and then run, because that's how much you would have to run from here to here to get from this point to this point. And it's also called the change in y and the change in x. So let's look at an example on how to find the slope of a line. Now here I'm given 2 points, and generally you don't have to graph the line to find the slope, but it's a good visual. So I'm going to go ahead and graph these 2 points. So -1, 5 there, and then 6, -2, 6, -2, and now I'm going to connect the 2 to draw my line. So there's a line that goes through these 2 points there. Okay. Now I could just look at the formula. Remember the slope formula that we just saw said to find the slope, we have to take our 2 y-coordinates and subtract them to find that distance. And so let's go ahead and do that. So we have 5 is the y-coordinate of my first point, and then I'll use the second coordinate, or the y-coordinate of the second point. and then divided by the difference. Now visually, that's what we just found is, or what we're going to find is, this distance from here all the way down to there, -2. And now we're going to find the distance between the two x's. And since I started with 5, I need to start with -1 in the denominator. And the order really doesn't matter, as long as if you start with the y-coordinate of the first point first, then the x-coordinate in the denominator should be the one that it's its corresponding x. And so then it'll be minus the x-coordinate of the second point here, 6. So now that computation on my picture is finding distance from here all the way to 6. So if I do the math here, the arithmetic, 5, this will be 5 plus 2 for that minus -2. And then down here, -1 minus 6 is -7. 5 plus 2 is 7, divided by -7. That gives me a -1. And if you want to write it as a fraction, it'll be -1/1. Now, if you do it with the graph, notice that you find this distance from this y to this y, and if you count, that'll be 7 units. And then from here to here, that would be another 7 units. But you have to be careful though, because here, this distance from here to here, notice your line is decreasing or going downward as you go from left to right, and that's why you end up with this negative. And so that's why it's sometimes better to use the coordinates to actually find the slope rather than just the picture. If you do use the picture, remember that if your line is dropping, the slope should be negative. In this example, we're going to look at what happens when you have a vertical line, and we're going to see what the slope is. So we'll take these 2 points that come from a vertical line, use our formula for m, or for the slope, and take, again, the difference between the y-coordinates, so 3 minus 5, over the difference between the x-coordinates, so -4 minus -4. So if I do the arithmetic, I get -2 over -4 plus 4. So I have -2 over 0. And we know that when we have a fraction, we can never divide by 0. That is undefined. So that means that the slope here of this line is undefined. So m is undefined. Now, what's happening with the graph, so you can see that indeed it is a, let me graph the line. So here we go, my x and my y. If I graph my points, here we have, let's see, -4, 3, so 1, 2, 3, 4 for -4, 3, 1, 2, 3. There's 1 point, and then -4, 5 would be here. So you can see there in line, and you get a vertical line. Let me graph that vertical line for us. So it's going through these 2 points. There's our vertical line. And so you can see the reason why we get an undefined slope for a vertical line, that is because there is no change in x. So when we find this difference down here in the denominator, since I'm not moving to the left or to the right, that difference is always going to be 0. And since I can't divide by 0, then the slope of any vertical line is always going to be undefined. So let's write that down as a note. So the slope of any vertical lines is always undefined. This time we're going to look at what happens when you have horizontal lines. So here I have 2 points that are of a horizontal line, and so I'm going to use the formula again. So 1 minus 1, now it's the same because both of the y coordinates are the same. And then the denominator I have 5 minus -2 for the x minus the x. Here 1 minus 1 is 0, 5 plus 2 in the denominator, so you get 0 over 7. Now 0 over 7, we can do that. That is defined. Anything into 0 is always 0. So you get slope of 0. So let's see what's happening on the graph real quick. Let's see. Let me make my x and y axis. So here's my x. Here's my y. And let's graph 5, 1. So 1, 2, 3, 4, 5, 1. Here's my point, 5, 1. And let's graph -2, 1. So -2 for the x, 1. And you can see that they're part of a horizontal line. Let me graph that line real quick. It goes from here to here. And so you can see kind of like what happened with the, this is my y and this is my x, what happened with the vertical line. Now here my y's are not moving up or down, so that there is no change to go from one to the other. And that's why for horizontal lines you're always going to get 0 in the numerator because you're not moving up or down. And so for all horizontal lines, so lines, the slope is always 0. So all horizontal lines have slope equal to 0.